Hey everyone, I'm just going to go through some things related to APR and APY and kind of tackle things from different angles and look at some different types of things to help hopefully make things settle in a little bit more concretely about annual percentage rate and annual percentage yield. So I want to start off here just talking about simple interest, compound interest, and continuous compound interest, kind of three big types of ways in which money can grow in accounts. So first of all, starting with simple interest, we oftentimes think about simple interest as being just the I equals PRT sort of formula, right? So that's actually giving you the amount of interest that's actually earned in an account directly when we use that formula, so that when we do P times R times T, that actually gives the interest that is earned in the account during that amount of time. Whereas when we think about compound interest, whether it's a finite number of compounds or if it's compounded continuously, usually those formulas that we think about are actually giving you the account balance, so how much is actually in the account. So for compound interest, if it's compounded like a countable number of times, that formula is the principal times the quantity of 1 plus r over n to the nt, like that. And then if it's continuous compound interest, that's going to be the amount is equal to your principal times that number e to the rt power, right? Yeah, and so then what we're kind of missing is we're missing in the simple interest case how much is actually in the account. So it does turn out that how much is in the account for simple interest is A equals principal times the sum of 1 plus RT. And remember that actually does come from, if I use the distributive property right here, the principal plus the principal times the rate times the time, which that principal times the rate times the time is actually just the interest, right? So if you take your principal plus interest you've earned, of course that's going to be how much is in your account, okay? And then if we wanted to specify here and here how much interest you've earned in your account in the compound interest cases, then all that you would just need to do is then just take how much is in your account at a given time and subtract how much you started with, and that tells you how much your money has grown, right, in interest. And then the same thing right here. It's just the account balance minus the principal. Okay? All right. So you see I have a couple more rows right here. So first of all, the APR. So remember that by definition, the APR is just the stated rate of annual percentage growth in an account in a year's time. And so in all of the cases, in simple interest, compound interest, and continuous compound interest, it's just R, right? So that number right there, and that number right there, and that number right there, right, that we use in those formulas. That's the APR. It's just the stated rate of interest. But as we've learned and talked about right here, right, the APY, that's the annual percentage yield. That's the actual percentage growth in a year, right? And so formulaically, they just come from like the simple interest and compound interest formulas. In the case of simple interest, your APY is actually always the same, right? But then in the case of the compound interest, your APY is equal to 1 plus r over n times. We don't have the t in the exponent because it's just a 1, right? Because we want it for 1 year. And then if you just subtract 100% or just the number 1 from it, then it just gives you the percent of increase, right? And then for the case of continuous compound, it's just e to the r times 1, so just e to the r, really, and then minus 1. And then I'll calculate your annual percentage yield in that case, okay? All right, so we'll kind of deal with some calculation sorts of things in just a little bit. So just first right here, just kind of scrolling down. So now what you see at the top right there is, do banks or credit unions more commonly advertise the APR or the APY for each of the following things, right? So the APY, right, is usually either going to be equal or higher, right? And then the APR is usually lower or equal to, right? And so banks are going to want to advertise the APR, something lower when they're charging you interest, right? And so for things like a personal loan or things like a mortgage, they're going to advertise the APR and make it look like they're not charging you as much, whereas actually you're going to get charged more because they're going to you're going to get charged at the rate of the actual yield, right? The APY. But in cases of things like savings accounts where you earn a little bit of interest, or money market accounts, right, which is just kind of a special type of savings account, as well as CDs, which is another type of savings account, just your money's locked away for a certain term. And then also checking accounts too, right, where you deposit money into. So any type of deposit account, they're going to be advertising the APY and make it look like the best that it will actually be. So yeah, you'll see that. And we saw that on a bank's website too, right? All right, so then now at the top here it says that if different accounts have the same APR, will they both have the same APY? The answer to that question is no, they will not necessarily. So if there's an account, let's say account number 1, and then another account, let's say account number 2, and let's say that, I don't know, R equals 2%. And then R equals 2%, which means that if it's just the R, then it's actually the APR, right? So the APR is 2% in both. So if there was a difference in how the interest was earned, so maybe they both are compound interest accounts, but if one compounds, let's say weekly, and let's say the other one compounds quarterly, then the compounding is going to affect the actual yield. And so since this guy right here compounds more frequently, because weekly happens more often than quarterly, then this APY is going to actually be higher. Without actually doing the math of this, I don't really know what it is. I'm just literally making that number up. So yeah, let's say it might be 2.04%, whereas maybe this one might be 2.02%. Okay, so again, that number and that number, they're not accurate, but just you get the idea, right? Okay. So jump into the backside here. Now I'm actually going to do some accurate calculations with this sort of stuff because it'll matter for what I want to drive across here. Okay, so it says here that if $10,000 is deposited into an account with a 2% APR of interest compounded weekly, then what's the balance after 1 year, what's the balance after 2 years, and what's the balance after 3 years, right? Okay. So since we are given this right here, the APR of interest, that's the actual stated rate, which when you're using interest formulas, that's what you're going to plug in for R actually. So if I wanted to figure out the balance of this account after 1 year, I would have to use the compound interest formula, and it's compounded weekly. So I'd want to use the one where I can do the principal, and then in parentheses 1 plus 2% as a decimal is that. And then we'll divide it by the number of compoundings. It says it's compounded weekly. So I'd have to use a 52. And then we raise it to the 52 times, and then in this case, just a 1, because we want to figure out the account balance after 1 year. So I will now actually take the time to type that in and evaluate that. And it gives us that amount right there. So we only made it to 97 cents, right? All right, excellent. So if we wanted the balance after 2 years, basically it's literally almost the same. The only thing I'm just going to change is it's going to have a 2 instead of a 1, right? So right there for 2 years. So yeah, then I'll type that in here. We just got to change that to become a 2. And we ended up getting $10,408.02. And then finally, we'll do it one more time to get the balance for 3 years. And that equals $10,618.24. Beautiful. Okay, so those are numbers that are going to become really important here. I need to define them to kind of demonstrate what's going to happen in just a little bit right here. So one more thing that I want to find, and then you'll see what I'm trying to get at here. So the one tiny little thing right here is now I'm going to try to find the APY of this account. And so we actually saw back here that for a case where we're compounding interest a finite number of times, that the APY could be calculated using what I just circled right there. So that's what I'm going to use to find the APY for this right here. So the APY is going to be equal to the quantity of 1 plus our APR divided by 52 to just the 52, and then minus 1. Okay, so I'll do that on the calculator here. And the calculator tells us 0.020197. Just kind of round it off there. Which then, if I move the decimal point over a couple places, it's 2.0197 percent, right? So that's actually, this right here is the actual annual percentage increase, right? So it's not 2%, it actually goes up by 2.0197%, okay? So here's really what I want to try to get at right here is I want to show and prove that the APY is the actual percent increase in the first year and then also in the second year and then the same thing also in the third year, okay? So what we can see happen in the first year is we ended up with that amount of money, $10,201.97. So since it went up $201.97 from $10,000, if I just take the $201.97, that amount of increase, and I make it a fraction out of 10,000, okay? I'm going to put that in a calculator. You can see that it's going to equal 0.020197, which that right there is the APY, right? So it just proves that that's the actual percentage increase, right? When we take the dollar amount of increase divided by the dollar amount we started with, right, we can see that percentage increase. So I just want to demonstrate that also is happening in the second year. So in the second year, we ended up with $10,408.02. So what I'd want to know is I want to know how much I actually increased in that second year. So what I'd have to actually figure out is if this is how much I ended with in year one, I'd have to figure out how much I increased by to get to year two right there. So I'm going to actually need to subtract my end balance from year two and my end balance from year one. And that tells me that there was a $206.05 increase in interest in just the second year. So I should be able to show then that if I took $206.05 right there, and then I took it as a fraction of how much I started with, which actually would have been the end balance of year one. So the 10,201 and 97 cents right there, that should also just equal the same APY. So I'll do that in the calculator here. And that equals, as you see on the calculator there, 0.020197. There's more decimal points, but it's the same thing, right? So we get the APY. So I think I'll just kind of leave it there. You get the points. Obviously, you could mirror that same sort of process in the third year and get the same APY, of course. Okay, so that's what we see happening with APY, right? All right, and then the last thing that I want to make sure that we address right here is that if $10,000 is deposited into an account and it has a 2% APY of interest, compounded weekly, what's the balance after 1 year? So this right here, if it's the APY, is the actual rate of growth, right? So this is not R. This is not the APR. This is not something that we can plug into a compound interest formula. It's not something that we can plug into a formula like that. It's just saying that it's actually growing 2% every year, right? So if I want to know the balance after 1 year, I know it's literally going to actually grow by 2%. So all I would just kind of need to do is take how much I start with and make it grow by multiplying it by 1.02. So it becomes 102% of itself because it's going to actually grow by that, right? I don't need to use a formula if I know the APY, right? And so since we want to know just the balance after 1 year, that's all I need to do is just multiply it by 1.02, and whatever that equals would give me my answer, right? If we wanted to figure out the balance after 2 years, though, what you'd have to do is you have to do 10,000 and then 102% of that. But then whatever you get right there, you'd have to do 102% of that, which really just leads to repeated multiplication of the 1.02 twice. So we could just kind of write it a little bit more simply and just say, okay, it's just going to be multiplied by 1.02 squared, right? And so just in a similar fashion, if we wanted the balance after 3 years, we could just do 102% 3 times, sort of like that, right? So obviously these are things that you could type and evaluate into a calculator, right? So if we do it just once, you're going to end up with $10,200, okay? If it grows by 2%. And then if we do that twice, you'll end up with $10,404 in that second year. So you actually gain $204 in that second year. And then if we do it with an exponent of 3, then we end up with $10,612.08, right? So we actually grew by $208.08 there in that third year.